Today we're going to talk about the properties of rectangles and rhombi. However, before we do that, I wanted to make sure that we review the properties of parallelograms. So last class we talked about parallelograms, right? Rectangles and parallelograms share the same properties. Parallelograms have opposite sides that are congruent, opposite sides parallel, opposite angles that are congruent, consecutive angles that are supplementary or adjacent angles that add up to 180, and then their diagonals cut each other into two equal parts. Okay? So because a rectangle is a parallelogram, it shares all of these properties. What makes a rectangle different from a parallelogram are these two additional properties. Rectangle also has 4 right angles, and it has diagonals that are congruent or equal to each other. So if we're looking at this in practice, because the sides are congruent, if we're given the sides, we can tell what the other two are. So PQ has to be equal to SR, and PS has to be equal to QR. Those are both 10, right? So QR would be 10 and SR would be 24. Okay. Now the difficulty then comes when we're trying to find SQ. SQ, which is the length of one of the diagonals, right? Let's take a look at that. So when SQ is right here, and we're going to use the fact that the diagonal is part of a right triangle within the rectangle to solve for the length. We know this is 10 and we know this is 24. So since we know that the legs of the triangle's lengths, we can find the hypotenuse using the Pythagorean theorem. All right, Pythagorean theorem is a squared plus b squared is equal to c squared, where a and b are the legs of the triangle, the portions that form the right angle, and c squared is the hypotenuse, always the longest side. So we'll substitute in the measure of the legs. We have 10 squared plus 24 squared is equal to c squared. 10 squared is, 100, and 24 squared is 576. That's equal to c squared. Now we add these two together, giving ourselves 676. It's equal to c squared. Now to cancel out c squared, the opposite of a square exponent is a square root. So we're going to take the square root of both sides. That cancels out the square exponent. Square root, or the number times itself, that equals 676, is I think 26, but let me double check. I do the square root of 676. Yep, 26. Excellent. So 26, and then the square root of c squared is just c. Cancels out. So our length of our diagonal, or the hypotenuse of the triangle we formed, is 26. Since we know the length of one of our diagonals, we can tell the length of the other diagonal because they are congruent. And we would also know the length of a half of the diagonal. QT is 1/2 of our diagonal, so it would be 13. let's look how we would solve that given some algebra. All right, if we have Jm and Mk, find Jl. Okay, so we've been given two halves of a diagonal, Jm and Mk. So our first goal is to figure out a way that these two are related to each other so we can solve for x. Okay, because they're both halves of a diagonal and because our diagonals are congruent, then we know they're equal to each other. So we can just set this equal. X plus 17 has to be the same length as 5x minus 23. Now we're going to solve. And guys, we're going to do it using Desmos because we're going to be doing a lot of algebra in the next couple of days, and we want to make sure that we're able to get that done at a decent pace. I don't want you guys to spend an inordinate amount of time doing the algebra. I would like you to be able to identify the relationships. So we're going to type this in. X plus 17 is equal to 5x minus 23. And by the powers of Desmos and some scrolling out, we find that x is equal to 10. Okay, so x equals 10. All right, so now that I know that x is equal to 10, we need JL. Okay, JL was the entire length of a diagonal. So there's a couple ways you can do this. You can add together the two halves, or you can take one of the halves and multiply it by 2. I'm going to take one of the halves and multiply it by 2. So I know that JL is going to be equal to 2 times JM, right? So JL is equal to 2 times x plus 17. Now I could solve this out, or I could just substitute in now, which is what I'm going to do. 2 is times 10 plus 17. So x is equal to 10. So 2 times 27, excuse me, or 54. So we know that JL is equal to 54. All right? Here's a problem that you can practice on your own, but I think this. All right, here we've just been given a single angle, but from that we can probably figure out the rest. So we know that angle J is a 90-degree angle. So if we've been given 27, we take 90 degrees and we subtract 27. That should give us the remainder of that angle, which should be 63. So we know this is 63 degrees. Now we can use alternate interior angles to solve for the ones along the diagonal. Okay, so we know that 27 also I'd have to be equal to 27 here, alternate interior angles, and 63 has to be equal to 63 here. Okay, so we're well on our way. So the measure of J, K, M, J, K, the full measure is 90 degrees. The measure of M, J, L is 63 degrees. The measure of J, L, K is also 63 degrees. And K, M, L. KML. How do you think we would figure that one out? So KML is also going to be equal to 27 degrees. All right. And then MNL is a triangle, MNL. We have 2 times, so that has to be equal to 180. So I have 2 times 27 plus n has to be equal to 180 degrees. So we take 27 and we multiply it by 2, which gives us 54. We subtract 54 from 180. Is 126. 126 degrees. Now it doesn't ask us for that, but we would know that this would be 126 degrees also. Okay, and we would know that 180 minus 126 would give us 54 degrees for the other interior angle here, right? And just in case you wanted to check, if you add 54 plus 63 plus 63, you would get 180, right? So we can find the rest of the angles. So we can use this information to solve for missing angles. Because we know that alternate interior angles, they have to are congruent. So I know that this angle is congruent to this angle. And because I know that the 2 angles have to add up to 90 degrees, I know that this whole thing is 90 degrees. So the x plus 20 added to 5x minus 8 has to be equal to 90 degrees. Okay, you can solve however you'd like, and then substitute back in to find the measure. Okay. Again, I recommend Desmos. I'll show you how one more time. Save yourself some time. Just do x plus 20 plus 5x plus or minus 8 equals 90. And we have got x equals 13. See where x crosses? X equals 13. So x equals 13. And if I want the measure of xzw would be this angle.